recording. There we go. Okay, so I went ahead and drew an x squared. It can be whatever you want, so I went ahead and drew this. What the mean value theorem is stating is that, let's say I have these 2 points on this closed interval. Well, we have this line. Do we recall what this line is called? The line that goes through 2 of the points. We call it a what? Line? Not a tangent, that's one. A secant. Very good. It is called a secant. So here we have a secant. And the secant, remember, the secant just stands for average change over time. So that is the average change here. However, there is not, if we want to do instantaneous, we could go ahead and use the tangent line, right? And make it there. However, ask yourself this question. Looking here, do you think, based on your graph there, whatever you drew, should the derivative at a certain point ever be equal to the average rate of change? Yes or no? So should the derivative, the tangent line, have the same slope as the average rate of change graph? Go ahead and take a second, consider it. So right now you see the average rate of change, right?
Yes.
Should there be a tangent that has the exact same slope as that, where the derivative is the same as the average change?
Yep.
Absolutely, yes.
Yes.
So right here, it's a line like this. However, many of you might have funky, strange functions. What if you had a function that looked like this here?
Oh my gosh, that's what
Should I have a graph? This is my average rate of change. Is there a tangent line that looks like this? Do you think so? Yeah, and there is. It's very true. This is called the MTV, or sorry, the MVT, not the MTV. MTV, great TV series. So sorry, great channel. So sad it.
It's reality
still
TV
there?
shows now. It's just
Yeah.
reality TV shows about rich people and cheating on.
They also just play like
Gino.
no.
So, the MVT, or the MTV, if that's how you remember it better, states that if f of x is continuous on a to b, on the interval a to b, and differentiable, then there exists one point such that the function at b minus the function at a divided by b minus a is going to be equal to f prime of some point c. So if you recall, f of b minus f of a over b minus a, that's just point, that's just slope right there. That's the slope equation. What this is saying here is, oops, I'll keep it over here for now, is that if I have that line from before, I should be able to make a tangent line somewhere on my graph that has the exact same slope. And so everybody, go ahead and try that out on yours. And remember, make your secant line first, and then try to find your tangent. So if I look over here, for this one it's going to be simple. Where do I have here? If I draw this line like right here-ish, it's a little bit too much. I think it's going to be like right, this down like right here. Look at that, there we go. So therefore, this point right here is my C value. Go ahead and do the same on yours. See if you can fill it in.
So where do
I think mine has like
I just can't do the same
Yeah.
graph as you.
You can. Where do you have a derivative of 0? At the? Well, no, remember, the derivative of 0, if you have a derivative equals 0, therefore you have a min or a max. So therefore, where's the derivative going to be 0? Yeah, draw a line at the top. Because remember, a tangent line is just,
draw one
yeah,
straight down?
like this. So you have this here. You want to make a line parallel to this. So where's the only way you can do that? Right? Okay. All right. Does anyone have a really interesting one?
Cutting back.
What happened there? Oh my gosh, this one?
Yeah. It's a function.
It's not a function.
It's a
So
nice
again,
vertical line test.
what happened there is Cody did this.
That's not.
Is that a function?
No, that's not what I did.
Is that a function?
Yes.
Cody, this is not second grade art, okay?
No, I actually drew a ruin.
No.
Caleb said to make it look autistic.
What?
I drew a ruin right here.
I did not
I'm gonna
say
pretend
that.
you said artistic and move on.
Yes.
Okay.
That's
Let's just move on from there.
Artiste.
Artiste. Remember that the derivative. What this is saying is what all this is saying is the derivative will be equal to the slope secant. Okay, let's try this one out real fast. So we're going to go ahead and show that the function x squared satisfies the hypothesis of the MVT on the interval 0 to 2. So let's go ahead and check it. Okay, we have, what is our f prime of x? It is going to be equal to 2x. Therefore, if I input into here f of b minus f of a, so f of b is going to be f of b minus f of a over b minus a, it is going to equal, well, what happens when I input, what is my a and b value? What is our interval? 0 to 2. So therefore, f of 0 equals 0. And f of 2 is equal to, 2 squared is 4. I have 2 minus 0 over 2, sorry, 4 minus 0, oops, over 2 minus 0. So this is just me finding the slope of the secant line, finding that average. This is the same thing as when we're finding average velocity. So it's going to be equal to 2 over 1. Then, now we just need to do the other thing where we find f prime of 2. What is f prime of 2 going to be? It's going to be 2, sorry, not f prime of 2. We want to find out, sorry, we want to find out when f prime of x will equal 2. We want to find out when the slope is equal to the derivative. And that is going to be when we have 2x is equal to 2. Divide both sides by 2, we get x is equal to 1. So at x equals 1, the tangent equals the secant. And there we are. Okay, do we have any questions on what the MVT is, really? Like I said, all it's stating is the derivative will be equal to the average slope at a certain point on any interval, as long as it's continuous and differentiable. Yes, Emma?
If you're not given the interval, will you have to do like the...
No, so if you're not, you will always be given the interval for this. Yes. I'm trying to think of a case in which you wouldn't be given the interval, but no, you will always be given the interval or an interval of some sort. Okay? No problem. All right. Now, we're going to go ahead and move on to talking about increasing and decreasing functions. This will be pretty much review, but I will show you how to use this to kind of better look at increasing, decreasing, and also mins and maxes in a bit. That's going to be not tomorrow, but the next day. So we have that f increases. So let's look at this graph here. This is going to be the very precise and formal definition of what exactly it means to increase and decrease. So let's say we have this function here. We already know it's decreasing from negative infinity to 0, and from 0 to infinity it's increasing. Here we have our definition. F increases from A to B, sorry, from A to B, if x1, my x values are less than the other x values, and correspondingly, f of x1 is less than f of x2. All this is saying is that if I have a graph and I have x1 here and x2 here, if x1 is less than x2 and f of x1, which let's say it's here, is less than f of x2, which let's just say it's here, are we increasing or decreasing? We are increasing. All right, sweet. That is the very, very precise definition. Let's go ahead and look at the decreases definition. F decreases from A to B if x1 is still less than x2, but f of x1 is greater than f of x2. All right, x1 is still less than x2, but in this case, we actually have f of x1 up here now, therefore it is decreasing.
Isn't x1 still greater than x2?
x1 is still greater than x2, yes, but since the y value is greater, we have to go down to get to the other y value. Remember, because when we talk about increasing and decreasing, we're always talking about from where? From left to right. So therefore, we're always looking at when x is smaller to when x is bigger. Okay, and finally, we have our what is called the corollary to this. If you don't recall, a corollary is a part of a theorem which sometimes is proven, but is not always the main purpose. It's just something that happens because you prove this, you also learn this, this, and this. These will be pretty short. Now, if f prime of 0 is greater than, so if f prime of 0 is greater than 0, so if f prime of x, just f prime of x is greater than 0, at each point from A to B, then f increases from A to B. If f prime of x is less than 0, then f decreases. So this is just us saying, this is where this corollary came from, of the fact that if the derivative is equal to if the derivative is greater than 0, if the derivative is positive, the slope is positive, which means we are increasing. If the slope is negative, that means that the derivative is negative, which means we are decreasing. Go ahead. I don't know. All right. Do we have any questions here? Any questions on this part? No? Okay. So now, here, we want to check. Here, where is the function f of x equals 2x cubed minus 12x increasing, and where is it decreasing? Well, what we are going to go ahead and do is use a sign chart. So use a sign chart. Y'all haven't seen sign charts much. We used them very, very briefly in pre-calculus. You might have seen them in advanced algebra 2 if you were Mr. Miller. He might have done them more. But what a sign chart is we're just going to be looking at the signs of the derivative, and that will tell us what is happening on certain cases. So the first thing we want to do with this equation is, well, when we want to find increasing or decreasing, recall, how do I know if something is increasing or decreasing? Well, where does the change happen? The change happens at the maximum. So we have to find out whether or not these graphs have any maximums or minimums. So we have to set the derivative equal to 0. So let's go ahead and set the derivative to 0. F prime of x, what is the derivative of 2x cubed minus 12x?
6x squared minus 12.
Thank you. And then we're going to set this equal to 0. Solve for x. We get x is equal to plus or minus root 2. Now, in order to make a sign chart, we need to find our zeros. So for our zeros, I look here, my two zeros are root 2 and negative root 2. So what I'm going to do is I'm going to make a number line here, like so, and I'm just going to label the 2 points. Negative root 2 and root 2. Then I'm going to draw the line through this, line through this. Okay. Now, all I need to do is I'm going to be checking what the sign of these are at specific points. So we know what's the value at negative root 2 it is going to be. If I input negative root 2 into this equation here, what am I going to get? 0. So I know these are going to be 0. So what happens in between zeros? When we cross the x-axis, the sign changes. So this is going to tell me, okay, well, where my sign changes are. So here comes the easier part. What is a number before negative root 2? An easy number.
-1.
That's a little bit too big. A number before negative root 2.
Negative root 2.1.
Think about an easy, no, unfortunately not.
Negative.
Negative root 2 is smaller on the left side. What is it?
Negative 2.
-2. So we can just do x equals -2. What easy number is in between negative root 2 and root 2?
0.
0. And what number is after root 2 that we can check?
Oh, I kind of remember this.
So what we did is we just chose numbers in between my zeros and after my zeros. Now what I'm going to do is I'm going to go ahead and check their sign. I'm going to go ahead and input these into my derivative. 6 times negative 2 squared minus 12 is going to be 24 minus 12, which is 12. And the answer here is going to be, are we positive or negative? We are positive. Okay, sweet. Then I look here. So if my derivative is positive, I'm going to draw a line here. What is happening to f? So this is f prime. This is f. If the derivative is positive, what do we know about the slope? The slope is? If the slope is positive, the derivative should also be positive. So therefore, are we increasing or decreasing? We are increasing. So therefore, if I input any number less than negative root 2, I will always get a positive number. We are always increasing. So now we do the same thing over here. What happens when I input 0? We get 0 minus 12, which is negative 12, which is negative. So therefore, are we going to be increasing or decreasing? We will be decreasing. And then what's going to happen at root 2? Well, let's input the 2 value. We get 6 times 2 squared minus 12, which is, again, 24 minus 12, which is? Therefore, it is positive. Is it increasing or decreasing? It is increasing. So, using this shine chart and the derivative, we were able to find all our values out. And also, we just did all the maximums and minimums on this graph too, which is kind of nice. So, when are we increasing and decreasing? Well, we are increasing from, how far are we increasing? All the way to the left, negative infinity, all the way to? Negative root 2, good. Then I am also going to be increasing from root 2 to infinity. Then I'm going to be decreasing from negative root 2 to root 2.
And those are all open brackets.
Yes, we're always going to do open brackets on these because we don't know if they exist or not. We could check, but we don't know when. It's hard to always say when it starts increasing versus decreasing, because at this point here, at the bottom, when the slope is equal to 0, it's positive or negative. The slope. Well, 0 is just 0, right? So therefore, it has no positive or negative, so therefore you just can't ask that question. That's why we're not evaluating them at these, because here, whenever the derivative is 0, it's min or max. There's no increasing or decreasing going on, so therefore we always do parentheses. All right, your homework for today is going to be Yeah! No,
Have fun. And relax.
Yeah, alright.
Just like Kobe's girl.
1 through 10.
Would my homework be to solve this with the student?
I
I had to figure it out.
Appreciate the
Your
practice.
final, like, that could be your additional
I just
homework.
use it.
Oh, my God.
Am I gonna be solving that?
You know
Could be like-
We're gonna do the cathedral?
We can just use AI.
No, use the Mega
You can just take a picture of it and I'll set you.
Mega Mix is in dodecahedron.
Ooh,
Yeah,
that
yeah.
is.
Solve the Mega Mix.
Not right now, no, unfortunately not. So, let's go ahead, Justin, so we don't scare ourselves, let's go ahead and look at this one here. Let's look at the first one. Wait, what did we learn tomorrow? We learned about anti-derivatives. That'll be a fun one.
It's like evil one.
Evil. No, it's the exact opposite. It's our start on integration.
It's bizarro. It's the opposite.
Okay, everybody, so what we have here is we need to state whether or not the function satisfies the hypothesis of the mean value theorem on the given interval. If it does, find the value of C. Awesome. This will be a nice and simple one. However, just to remember, how do we know if something, the only time we can use the MTVT is if it's on the interval, it is differentiable and continuous. So, we have to check. Is there any issues here? Any do not exist anywhere? No. So therefore, we can say, no, there is not. So I can go ahead and say, this is good, this is checked. It is continuous and differentiable on the given interval. So we're good. Then we go down here, the values of C that satisfy the equation. Well, I need to do the average change. So first I'm going to do f of 1 minus f of negative 3 divided by 1 minus negative 3 to give me, if I input 1, I get 5 plus 2 is 7 minus 3 is 4. Minus input negative 3, you get 5 times 9 is 45. Plus negative 6 is 39. Minus 3 is 36. Can someone check me on that?
Yep. Yerp. That's right. Yerp. 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 Do we have anything in physics today, Kevin?
What?
What have you
Dude, I'm in your class.
Yeah, do we have anything?
I don't know. It would be minus negative 3. Wait. Oh, never mind. Do we have homework?
Yeah.
Okay, am I good on this? My numbers check out?
Go check out.
Sweet. So then we get that this is equal to negative 8. So now all I need to do is take the derivative of this function. F prime of x is going to be equal to 10x plus 2. And then what do we want our derivative to be equal to? We want to set it equal to?
8.
Nope.
Negative 8.
Negative 8.
Woo-wee.
Because remember, this is not when we're finding mins and maxes or anything like that. We are finding out when the MTV is working.
I just don't like it, Connor.
And notice it says FTV and not MVT. So we get 10x plus 2 equals negative 8. Subtract 2 from both sides. Divide by 10. We get that x equals
We can't see it.
negative 1. Okay. So therefore, the value of C that satisfies the equation is, in this case we only have 1, so x is equal to negative 1. So that means that we have a tangent of negative 8 at negative 1. Again, all we're doing here is we're using, let's say, this point and this point here. That's the secant. Therefore, there should be some tangent that is, that is perfectly parallel. Okay? All right. Go ahead and continue working on your homework. I honestly don't think this will be too bad, but let me just skip around to make sure.
Wait, what was the numbers again?
The other
1 through 10.
Pretty cute.
You have 10 minutes to work on these now. I would definitely suggest it because we will have a PC over the next 2 lessons on Friday.
Yeah.
When's our quiz?
Yes, you may. Our next quiz, I believe, is on Wednesday. Once Henry gets back.
Do we have that? Stop.
When
You want me to just know what the graph
What do you think you do for 6 or which one?
Honor this ring and tear
It's not on there.
Are you gonna for Asian?
No, she's not going to do
Oh, this is math? No, it's a sweet.
That graph's shoot, I already messed it up.
Wait, was Swiss a graphic?
Oh, I had it.
Okay, I mean, unless you know what it looks like.
5 times
Wait, what is this
9.
equation? This,
Great.
When you see F,
oh, gives you the slip basically.
yep, and F of 1. You put 1, so 1 minus 1. And then 1 minus negative. Square is a negative.
Yeah, it's a slip the secant. Oh yeah, it's a split. Oh yeah, obviously.
To input, whenever you have this, just input it.
I'm
So
actually.
here, I'll show you. F of 1.
Now, wait, how do we find it for
1
the
minus 1 is a 2.
Yeah, it was what was it?
Negative 1
The derivative.
negative positive 1
What if it's just different?
minus negative 1.
Find the derivative.
Okay?
This is the first question. How do you know if it's differentiable without a calculation? The function is continuous and
Go
differentiable.
back up, you mean?
Oh, there's
Okay. Did we just
Right there?
No, I think I found it. Should I find a derivative?